Hello, my dear friends. You are welcome to Joe Newton online class. Here we want to study, of course, solve this particular question on the board, which is taken from the topic wave in physics. Now, without wasting time, we should record the common terms used in describing waves, which include frequency, wavelength, velocity of waves, the period, and the amplitude, and so on. So let's look at the question and know the one that is involved in our task. The question says that a radio station broadcasts at frequency of 600 kilohertz. If the speed of light in air is 3 times 10 raised to 8 meters per second, calculate the wavelength of the radio wave. Okay, then in solution, we record the relationship between the frequency of wave, the wavelength, and the velocity of wave. And that relationship is this, that F, or rather, the speed is equal to F lambda. That is, speed of wave is equal to what? Frequency times what? Wavelength. Lambda is the wavelength, F is the frequency, V is the speed or velocity in meters per second. Of course, the frequency is in hertz and the wavelength is in meter. Okay, but looking at what we are given that the frequency F is equal to 600 kilohertz, very high frequency. Now, the standard unit for frequency is hertz, but this is in kilohertz. So do not make mistake of working with it direct. You convert to what? Hertz. Remember that anything kilo is a quantity in thousand. So 1000 hertz is equal to 1 kilohertz. Therefore, 600 kilohertz will be 600 times 1000 hertz. Of course, that will give us 600,000 hertz. Let us use standard form anyway, since we have long digit there. That will give us 6 times 10 raised to power 1, 2, 3, 4, 5 zeros, to 5 hertz. Good. Okay. Then we now continue. We have that the speed of light in air is given to be 3 times 10 raised to power 8 meters per second. It is noteworthy you remember that even if this is not given, that the speed of light in air or in vacuum is constant. That is speed of radiations in air or vacuum is what? 3 times 10 power 8 meters per second. Okay. Then we are asked to find the wavelength. Now, referring to this equation, we are looking for wavelength, lambda. We are looking for wavelength, which is lambda. We are looking for lambda, the wavelength. So from the equation, we have that our F, we are looking, since F is equals, V is equals to F lambda, therefore, our lambda now, taken from this equation, our lambda will be equal to V divided by coefficient by F, that is speed over frequency, which is equal to, what's our speed here? Our speed is 3 times 10 raised to power 8. All over, our frequency is now 6 times 10 raised to power 5. Then, which will give us, using standard form, we will now have that, we'll have 3 over 6 times 10 raised to power 8 minus 5. Because in standard form, division, this line, quotient line division is minus in power. So that will give us, this will give us 3 over 6 is 0.5, that is 1 over 2. So we have 0.5 times 10 raised to power 8 minus 5 is what? 3. Then, which now becomes, this is in fraction, decimal, so we make it to a unit whole number. Then when you borrow 110 here, to make this a unit whole number, you will get what? 5. When you borrow 110 from up here, times 0.5, get 5. So you have 5 times 10, 5 times 10 raised to the power of 2, or 500 meters. So in meter, so that's our answer. That's our answer. Because this 0.5 times 1000, 10 raised to the power 3 is 1000. So 0.5 times 1000 will give us what? 500. That is half of 1000. Or 5 times 10 raised to the power 2 in meter. Thank you so much for paying attention to this particular class. I believe you can solve similar tasks when you meet it. For more of these solutions in physics and mathematics, you visit my YouTube channel, subscribe for updates of tutorial videos. Also, follow me on Facebook and even TikTok. Then click like and share for others to learn as well.